Hello everyone, Michael McEleney here with a brief explanation of our sous vide made for our Robot Sensors and Actuators class at the Johns Hopkins University.
We're going to begin with a brief overview of our circuit. As you can see, most of the components of our circuit were constructed on a breadboard. The pins on the leftmost edge of the breadboard are connected directly to a Mavarm microprocessor chip, which is driving most of the logic of our sous vide's operation. As we zoom in a bit, you can see there's a lot going on, so I'm going to break it down component by component. The black wire you see extending out of the bottom left corner of the image is connected to a temperature sensor with a processor on board to calculate the temperature. The button you see near the center of the image is used to confirm whether or not you want to select thermostat mode or PID mode. Finally, the LED in the top right corner comes on whenever the heater is turned on and turns off whenever the heater is disabled. As we move to view the lower half of the circuit, you can see there are two key components here. The first is the button on the left, which controls the motor, which we'll get to later. The second is the joystick on the right, which is used both to control which mode you want to put the sous vide in and to adjust the temperature. Here's the relay, which controls whether or not the heater is on. And finally, here's our pot containing both a heater, again controlled by the relay, and a circulator pump, which ensures that the temperature of the water is roughly even throughout. Oh, and don't forget about the motor. The wooden block on the right may seem unassuming, but underneath there's actually a motor that spins whenever the button is pushed on the board. This is done to display our food in a manner that is aesthetically appealing and readily advertises our delicious s'mores. We're now going to begin a brief demo of our sous vide in operation. As you can see, the board is turned on, and we're going to move in and take a quick look at the LCD screen here. Now if you look, the screen displays two modes, thermostat mode and PID mode. We're going to select PID mode for this demonstration. As you can see, we're going to push the button to get things rolling, and the temperature defaults to 50 degrees Celsius. We had already turned the pot on prior to this, which explains why the temperature is already so high. Using the joystick, we can increase the temperature, and as it eclipses the current temperature, you can see the LED turn on, indicating that the heater is on in the pot. As you can see, the circulator pump is moving water around while the heater is on. As things get hotter, the temperature will be reflected on the LCD screen. We're now going to show you the variation of our PID controller to show you how accurate we get. But be warned, the fluctuations you're seeing will be displayed at an increased rate because we're going to fast forward through this because it's really boring to just watch an LCD screen. And finally, the thing we've been waiting for this whole time.